Hi and welcome to the series of tutorials on Hibernate. In this series of tutorials, we're going to look at what Hibernate is, how we can use Hibernate in our applications, and we'll also understand the features that Hibernate provides. So what is Hibernate? Hibernate is something called as an ORM tool. If you don't know what ORM means, we'll have a look at that in just a minute. Hibernate is actually much more than an ORM tool. There are a lot of features that have been added to Hibernate over the years. But when it first started, it started as an ORM tool. So it's used primarily in the data layer, where you want to persist your application data into a database. Thirdly, it implements JPA. JPA stands for Java Persistence API. This is a set of standards that have been prescribed for any persistence implementation that needs to be met in order to get certified as a Java Persistence API implementation. So what this means is that it follows the rules that have been set in the Java Persistence API specification, so that later, if you don't want to use Hibernate, you want to use some other provider which implements the same Java Persistence API, you can do that with minimal code changes. We'll have a look at what these are in more detail in the subsequent tutorials. But first, let's try to understand what an ORM tool is and why it's required. So what is the problem that Hibernate is trying to solve? Let's take an example of a simple class that you have in your application. I have a user class example here. It has 5 fields: the ID, the name, address, phone number, and the date of birth of a user. Now, in a running application, you would have a lot of such objects in the memory. Say I have 5 users in the application. Let's try to simplify it for the example. I have 5 users and the data of 5 users, and my application is actively using that to function. Now, I would have 5 user objects in my memory. Now, let's say I want to save these user data. Now, how would I do that? I would use a database, and 99% of the time we would be using a relational database, because that is the most common database, at least as of today. So I would have to persist all these user objects into the database. Persist is again another word for save. So I would have to store all these user objects and the data in those user objects into the database. How would I do that? I would have a user table, and each of these user objects would have data for a particular user, and I would save them as rows in the table. So what would happen is I would have this table like this. I would call this the user table, and I would have 5 columns that correspond to the 5 member variables of this user class. So each of this data has to be saved. So let's say I have user object number 1. I would save this as row number 1 in this table. User object number 2 would be saved as row number 2. So depending on how many objects I need to save, I would have so many rows in this table. So a class corresponds to a table, and an object of the class corresponds to a row in the table. So this is something that we have been doing over the years. And what we normally do when it comes to a Java application is we would normally use a JDBC connection, and we would connect to the database, and then we would take this user object. Let's say I wanna persist user object object 1. Now I would take this user object and I would pull up all these fields, and I would create a SQL query that would do an insert, and I would insert it into this database. So depending on what the user's information is, those data would go as a SQL query, and it would do the insert. The same way, if I need to create the user object, I would have to do a select on this table, and once I do a select, I would probably get a record set. Now I'll have to parse this record set and pull up all the individual data, and I will have to create a new user object, and I will have to feed in all the data. Say I've got user ID 1. Now in this new user ID, I would have to do a user.setID, and I have to give the value. User.setName, I would have to give the name. So depending on what I've gotten in the record set, I would have to create the object. So the problem here is this. I have objects here in Java, but I do not have objects here in the database level. This is a individual entity that needs to be converted to this individual entity, which is a row. And the way we normally convert it is by using some boilerplate code which takes each of these properties, takes each of the values of the member variables, and maps it to SQL queries. Now, this mapping is what is a pain. I need to convert each object into a SQL query and for saving, and then for retrieving, I'll have to convert a record set into an object, and I need to do this for each and every object. Say I have another class here, there would be another table, and I'll have to do the conversion every time. So this is a common problem, to put it mildly, because it's there in every Java application that has a persistence layer, and it connects to the database in order to save and retrieve values. So what are the problems that we face here? What are the pain points? The first pain point, as I told you, we need to map the member variables to the columns. Each and every member variable that we have to persist has to be mapped manually. Of course, you can have a procedure for each of the objects, and you write the code once, but you still have to do it. Now let's say I add a new column or I add a new field in my object. Now I'll have to make those changes in the code in order to map it. I will have to go to that particular loop, say, where I'm pulling up the record set data, and I need to add this extra field so that from the record set I pull up this extra field. So any changes have to be done ourselves we need to write our own code in order to accommodate those changes. And even otherwise, even if you're not doing any changes, you need to write the code in order to map this. The second pain point, mapping relationships. Now we saw a user object and a user table. Now let's say a user object has a reference to an address object. Now how would it work? We would probably have an address table. In that case, I would have to map the user object to the user table. I have to map the address object to the address table, and if there is a dependency between these two objects, I will have to create a foreign key and then map it to a primary key. So the address table's primary key would be mapped as a foreign key of the user table. So this relationship also has to be taken care of. The third pain point, handling data types. Now let's say I have a boolean in my user object, says active user. Now I want to track whether a particular user is active or inactive. So I declare a boolean and then I give a value of true or false. Now how do I do that in the database? Most of the databases do not have a boolean data type. It would probably be a char, so that I can save a y or a n, or it might even be an integer where I would say a 0 or a 1, or I could have different data types which have a representation of a true or a false, but they're not really a boolean. Now I will have to handle this data type conversion myself when I'm actually writing the code to save the data or to retrieve the data. So this manual handling again is a problem, because if you are making changes, you have to go to that piece of code and then make the change in the code itself. Okay, fourth pain point, managing changes to the object state. Now I pull up the user information. I want user ID 123. Okay, I pull it up from the database. I have a record set, and then I create an object and I put all the data into that object. I have the object ready. Now I pass it on to the business service. Now the business service does some changes to this object. It updates, I don't know, the email address, or it updates the name, something. There's a change. Now how would I manage this change? I will have to, again, manually execute the procedure. When I say manually execute the procedure, I mean that there has to be some other component which calls this procedure to make this change. It would have to trigger an update query. And what would be updated? Again, we will have to frame the SQL query ourselves. And depending on the value that is changed, we will have to update the database in order to accommodate the change. So again, this is something that we need to handle ourselves. So these are common pain points. We see this in each and every application. There are a few others, but I'm just highlighting these because these are something that we would definitely handle when we are writing an application that interacts with the database. And what's happened is many times, because of all these problems, you would normally have an object that maps to a table. So you say I have five tables. I would have 5 objects, and most of the times I've seen this happen a lot. We would not worry so much about establishing object relationships. Let's take the example of the user and address. Now, a user has a particular address. A user row in the user table has a corresponding address row in the address table, and it has been mapped by a foreign key. Now, ideally, if I have to represent this as an object, I would have to have an address object, and then I would have to associate it with the user object. But what I would do is, since it's a pain to establish this relationship depending on the primary key and the foreign key, I would treat it as separate objects, and I would establish the association based on the key itself, even in the Java layer. This is actually a very bad solution, and I wouldn't say it is common, but I've seen this happen. It's tough to maintain these relationships and to maintain the whole object state, because what's happening in the relational side is completely different from what's happening in the object side. So there is this huge gap between a relational way of doing things and the object-oriented way of doing things. So what usually happens is, since we cannot change the relational part of it, we have to save this in the database. It has to go to tables. The data has to end up as a relational set of data. So what usually happens is people tend to compromise on the object side of it. We would not have proper object-oriented programming, and we would tend to compromise on the object-oriented design, just because it's a pain to manage all of this. And what happens is our object-oriented design is influenced by the relational state of what happens to the data in the end. So this is a big problem, and this is something that many people have tried to address over the years, and there have been solutions which handle this elegantly, and we see more and more solutions which provide more and more elegant ways of handling this. And ideally, a solution that addresses this problem will help us map the objects with the relational database. Hence, the name of what the solution is trying to do is called Object Relational Mapping. So this is ORM, and this is the primary reason why Hibernate even came into existence, in order to help the users to map such a thing. And it's a framework which addresses this, among other things, and the primary use is to map this gap between objects and relational databases. In our next tutorial, we'll have a look at how we can write a simple Hibernate application which uses this Hibernate framework in order to save a user class into the database. See you in the next tutorial.